Hello everyone, welcome back to this channel. This video is part of a mini-series that aims to look at different data formats and some useful libraries that could be used to process and parse those data formats. In this video, we will be looking at structural data formats. So without further ado, let's jump over to Google Colab and look at the different types of structural data formats. So the first type of data format that we will be looking at is the comma-separated values data format, also known as CSV data format. And the main use case for this type of data format is to store simple tabular data. The main libraries you could use to perform data analysis or to read those CSV files is Pandas and NumPy. But we don't really need NumPy to perform data analysis at the moment. And NumPy is just a useful Python library that can help you perform some high-level mathematical operations for multi-dimensional arrays and matrices. So as you can see, we're using pandas read_CSV to read the dataset from TensorFlow. And to do that, we pass it the path or the link of the dataset, and we can modify the column names. So this is the column names. We can, for example, if we wanted to, we can change the column name diameter to, let's say, D. And once we run this and look at the first 5 rows of this dataset, we can see that we have different columns for the Avalon dataset. And let's put it back to diameter. You can see that this is the CSV file that is read as a data frame. You can perform other statistical analysis of the dataset that you have. You can use the .describe to look at different statistical information about the dataset. You could look at, for example, the unique values of the age of the Avalon and the dataset using the .unique method. And I've got a lot of videos on useful pandas commands that you could have in your toolbox while performing data processing and analysis using pandas. I'll be linking them down in the description below. The next data type that we will be talking about is the JavaScript Object Notation data type, or JSON. JSON is a data format that is typically used for hierarchical data and APIs. The Python libraries that you could use to process, to read JSON data are either JSON or JSON. The following code snippets will allow us to look at what a JSON file is and how we can read it through using the JSON library. The dataset that we will be looking at is one that is provided by Google Colab, and you can find it under the sample data section in your Google notebook, your Google Colab notebook. And to describe this dataset, it's an Ncombe quartet dataset that will comprise 4 datasets that have X and Y coordinates, as you can see over here, where each of those datasets have identical statistics that describe them, however, have different distributions. And so when we plot these, you would see different plots, despite them having the same descriptive statistics. Anyways, so if we wanted to read this through JSON, we can use the json.load command through opening the JSON file that we want to open. So using the with open, we provide the path of the JSON file that we want to read, and then we can load the JSON into an object, and we can even convert that data_JSON into a data frame using the pandas.dataframe. Now, what if we wanted to read the JSON through pandas? We can do that as well. To do that, you would just need to use the pandas.read_JSON and pass it the path of the JSON file, and you could easily read the JSON file as a Pandas data frame. What if we wanted to create a JSON file from a dictionary, let's say? And let's say we have the marks of 3 students from different majors, and we wanted to dump that dictionary into a JSON file. We can visualize this dictionary as a Pandas data frame just to understand how it looks like. As you can see, we have 3 columns and 3 entries for different columns. We have the names of Sarah, Adam, and John Doe, and their grades. To dump the dictionary into a JSON file, you just need to open a JSON file and put the operation mode as a write operation and use the json.dump command to dump the JSON file into the path that you've specified. Okay, now we will take a look at another data format known as XML or Extensible Markup Language. It is a language that is designed to interpret both human and computers altogether. And it defines a set of rules to encode a document in a specific format. So if you have a document, you can put some comments onto this document, for example, to specify that this sentence is the title of the document, or this word is the author of the document. And these comments are called XML tags. In general, when we read the data from an XML file, we talk about this process as parsing the XML file or XML document. There are multiple libraries that you could use for the purpose of parsing the XML document, and you can either use Beautiful Soup with the LXML parser or the ElementTree library. And in this example, we will be using the ElementTree library. The main reason for using the ElementTree module is that it provides us many tools for manipulating the XML files, and it is very much built in with Python's library. Therefore, you don't need to really install any external modules to do the purpose of parsing the XML files. Okay, so what is the dataset that we'll be using? We will be using the W3 Schools XML example file, where it is a small catalog of plants, and that catalog has stored different categories or properties or tags that describe plants. And those properties are like name, botanical name, light conditions, etc. After downloading our dataset, we could take a look at and inspect and parse the XML file or XML document through using the xml.etree's element tree, and we've imported it as ET. We then parse the XML file and take a look at the root through the get root. So when I open up the XML file that we've just imported, we can see that there's a parent root called catalog, and it has sub-elements that are made up of other sub-tags, such as common, botanical, zone, etc. And within each sub-tag, we have some text. So the catalog has a lot of plant tags. So when we parse this XML file, we expect to get the root as follows. So when we print out the root, we expect to get the catalog value. Look at the first or sub-element of the parent sub-tag. We can do that through the index of 0. And we can see, just as we've seen in the XML file, for the catalog tag, we have a sub-tag of plant. Let's say we wanted to look at the sub-tag of plant. We can do that by looking at the 0th index. For example, let's say we wanted to look at the common subtag. We can do that through looking at the 0th index of the plant subtag and look at the text of that specific subtag. So I'll change this from 1 to 0 so that we can look at the common subtag text, and we should expect to get bloodroot. So when I run this and print it, and of course you could do a lot of data processing of XML files using this library, but since this is just a general overview of what or how you can read and parse different data formats, we won't be getting into more detail. However, we can also take a look at how we can create our own XML file. So if we wanted to do the same as we've done for the marks dictionary above and converting it into a JSON file, we can do the same for an XML file. We can first create an element using the .elements method and store that into data. We can add subtags to that parent tag through the use of sub-elements. So let's say we wanted to create a subtag for marks called university. And we can do that using the sub-element method. What if we wanted to create a sub-element for the university subtag? We can do that as well using the same command, and specifying that we want to create a sub-element for the subtag 1, which is called university. And those sub-elements would be names and grades. If we wanted to specify some text, just as we've seen from the data that we've imported or the data that we just looked at, we can use the .text to fill in those sub-elements with whatever we want it to be. So in our example, we can fill in a text for the subtag names as Sarah Smith, and for the subtext or subtag of grades, we can fill in it with a 4.0. Now, what if we wanted to export what we've created, the structure that we've created using the ElementTree library into an XML file? We need to first convert it into a binary file using the .toString, where we pass it data that contains the whole hierarchy of elements, and then we can write to an XML file using the right binary mode of operation to create the XML file that we want. And looking at that XML file, we can see that we have a parent node of marks, a sub-element or subtag of university, and within it we have two subtags or sub-elements of names and grades, and we have text for both of them. You can also read in the XML file using pandas.read_XML, where you can automatically read in the XML file and have it as a data frame to do other processing tasks too. Finally, we have the Parquet or Avro or ORC data formats, and these data formats are commonly used in use cases with big data and analytics. And to handle these data formats, you would need to use PyArrow or Fast Parquet for Parquet files, or Spark for all of these data formats. The following is an example of what a Parquet file may look like, and we will be using PyArrow to process Parquet files. The dataset that we'll be looking at is the New York City open data regarding traffic, regarding taxi trip data. So it contains the timestamps, it contains the locations for pickup and drop-off, and distances and fares, or prices of those trips. After downloading the dataset, we can also install PyArrow, since it's not a default library in Google Colab. And after installing it, we can take a look at the dataset through using the module PyArrow.Parquet, and we can read the Parquet file as a table using the read_table of PyArrow's Parquet. And after reading that table, we can look at the schema of this table through using the .schema. So when we print out the schema of the Parquet file, we can see that there are multiple columns with different data types. So we have the vendor ID, which is an integer 64 type. We have different columns, as you can see. And if we wanted to, we can convert that table into a Pandas data frame to make it easier for us to process through using the .toPandas. So we pass it the table, and then that we've just read using Parquet, the PyArrow Parquet module, and we use the .toPandas to create the data frame for us to later be able to perform data analysis and data processing. What if we wanted to create a Parquet file? We can do that through, for example, creating a mini data set or mini data frame from the original data frame. Let's say we wanted to create a Parquet file with only 3 of the columns that we have. So the vendor ID, the passenger count, the trip distance. To do that, we need to first convert this data frame into a table, so that we can write that table into a Parquet file. So we use the Parquet, the PyArrow Parquet module to write the table into the Parquet file, but we pass it the PyArrow module that converts this data frame to a table from Pandas. We can also use Pandas to read Parquet files as follows. We could use the pandas.read_Parquet, pass it the path of the Parquet file, and as simple as that, we can read the Parquet file. Thank you so much for watching this video, and if you've enjoyed it and found it useful, consider leaving a like or subscribing to the channel. You can also support the channel by becoming a member or through becoming a Patreon. And as always, I'll see you in the next one, where we will be discussing other types of data formats and libraries that you could use to perform data analysis on those specific data formats. Thank you for watching.